So in this tutorial, we'll be looking at carbon storage in the biosphere. And I think the first thing to note is that the world has many different biomes and ecosystems, and each ecosystem interacts with the atmosphere and sinks carbon in its own way, particular to the characteristics of its ecosystem. So the largest sink of carbon within the biosphere can be seen in tropical, subtropical forests, which sinks roughly a quarter of all carbon. The second largest sink is boreal forest, which is found in these northern latitudes. And it's quite interesting to look at the differences in carbon storage within these different biomes. So if we look at tropical forests, you can see here that the vast majority of carbon is stored above ground and is sinking carbon through photosynthesis. There's a large amount of carbon stored within the soils and subsoils. But if we compare that to the boreal forest, you can see a much smaller amount of carbon above ground, so much slower rates of photosynthesis, but vast quantities of carbon stored in both the topsoil and subsoil layers. You can see there's a great difference in variety of carbon sinking going on in terms of the above soil vegetation layer and those subsoil layers. So I think at this point it's important to look at how carbon is exchanged. So carbon is exchanged between different stocks in the land, ocean and atmosphere. And these changes in stocks can be dynamic and vulnerable to shocks and changes. Carbon that enters or leaves the stock is referred to as a flux. The average rate at which carbon flows through a stock is called the carbon turnover. So you can see on the right-hand side that the turnover rates of different vegetations, different ecosystems is quite different, with slowest turnover here found in tundra, followed by boreal forest, fastest turnover found in tropical forests. So this reflects that ability of the carbon to be sunk through photosynthesis and rapid tree growth. So the turnover of carbon within ecosystems across the globe gives an idea of where carbon might be most vulnerable to releases in CO2 into the atmosphere. So slowest turnovers, due to carbon taking so much time to sink, are more sensitive to climate change. Although this will be subject to spatial differences. So for example, some areas of tropical rainforest, particularly in South America, are really quite vulnerable to climate change. So as I said earlier, these carbon sinks in the biosphere are dynamic and they're fickle, and they're vulnerable to disturbances. So warmer temperatures, extreme weather, and the increased frequency and severity of these disturbances can all have an impact on storages of carbon. So drought, wildfires, blowdown, pests, infestations, disease, all this is going to add stress to ecosystems. And we're seeing this already. So, the Western United States, Australia, seeing great variability in factors such as wildfire occurrences. We're seeing greater fire extent, more severe fires. So in Western United States, there's a greater variability in wildfire occurrence, and this is leading to high tree mortality from bark beetles. And large disturbances are generally expected to increase. Australia, USA, Europe, even large parts of Africa, although that gets hardly any media attention, are increasingly seeing forest fires. And then finally, the boreal forests are especially vulnerable to climate change. And the decline of these systems leads to a kind of dramatic carbon emission change or loss. Remember, the soils there have got much greater stores of carbon. So boreal and northern species within temperate systems also face potential declines as climate conditions become less suitable in the future and biomass shifts towards ecosystems more tolerant of hotter and drier conditions that typically will store less carbon. So while new species may shift into these ecosystems, the pace of that of natural species migration is expected to be substantially slower than the changes in climate. So substantially slower than those shifts and changes in carbon fluxes. And we can see that kind of fickle nature of land sinking carbon. You can see here, this is the annual absorption of carbon emissions. And whilst with the oceans you get a fairly steady kind of increase in sinking of carbon, what we see here in the green is that the biosphere is far more fickle and prone to change year on year. And so we get this dramatic shift in the ability of biospheres to absorb carbon. That's compensated by increased atmospheric absorbing or sinking. I'll just skip that through because I think we've been through that, and I just want to just take a look at the critical thresholds and look at one example here of forest dieback. So trees are responding to drought conditions, and first of all they brown leaves, and then you see premature leaf drop, and this extends when we see partial dieback within trees, where you get the twigs breaking off and stems dying back. And eventually what we see tree mortality. So trees die above ground and below ground. And as we move through climate change into periods of severe drought, this will only increase. So the distribution of tree mortality, as you can see with this map, is really quite a significant problem. So we've got recorded examples here, really quite global problem here of tree mortality and forest dieback. So extensive tree mortality and widespread forest dieback linked to drought and temperature stress have been documented recently on all vegetated continents. Even in the Amazon, we're seeing a greater sensitivity here to carbon. So the Amazon carbon sink is saturated, taking up a third less carbon in the past 10 years. So according to the study here, our brain in March 2015.